70 climbing stairs, and we're going to do it in Ruby. So you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. How many distinct ways can you climb to the top? So we can make a bunch of combinations just using 1 or 2 steps, depending on n, the target. So if n was 2, there's only 2 ways to climb to the top. That's 1 step and 1 step, and 2 steps. 3 would have 3 combinations. And the hint here is to reach nth step, what could have been your previous step? Think about the step sizes. This question can be solved using the Fibonacci sequence, where the next number is the sum of the previous 2 numbers. So 3 is the sum of 2 plus 1. Then there would be 5 because 2 plus 3 equals 5. Then 8 because 5 plus 3 equals 8. Then 13 because 8 plus 5 is equal to 13, and so on and so forth. So the first way I could solve this is by creating an array of that Fibonacci sequence and then use n as the index position to get that number in that Fibonacci sequence. That kind of tells us that if n were 5, then there could be that many combinations possible. So in order to create an array with the Fibonacci sequence, I'm going to create an array called fib, and I'm going to precede it with 1 and 2 to start it off with, because that's how we can start to get 3, then 5, then 8. So from this for loop for I in 1 all the way to n, do, and if it were for, I'm going to start at 2 because 2 is index position 2 right here is where we'd want to start adding it in, adding those new numbers in. So I'm going to do fib at position of I, which is our new spot right here, 2, insert something new. That's going to be the sum of fib at I minus 2 plus fib at I minus 1. And then this whole for loop will fill our Fibonacci sequence array. And then at the end of it, we just return fib at the position of n. Might be n minus 1 because this is 0 indexed. So I'm going to run this and submit it. So this one works for our extra space approach, because we're creating a brand new array and we're filling it up with a bunch of more values. It would be big O of n space and big O of n time, because we're looping from 2 all the way up to whatever n is. So that's for that solution. And then another solution we can go about is using, we could have, instead of allocating a brand new array and filling it up with new values, we can use 2 variables and pretend they're like 2 pointers that are moving from left to right all the way until they reach the end, and the first pointer on the left side would be the answer. But we're creating a Fibonacci sequence sort of just using these 2 pointers, and you're returning the first value on the left side of it, because once you get all the way to the end, that would be your answer. You're at you end up at that exact position on the Fibonacci sequence, so that's how you would get your answer. So I would have a left pointer, set that equal to 1, a right is equal to 2, so we could start it off. And then you can do also another for loop for I in. This time you could do it from the beginning. So you do I in 1 all the way to n, do, end. So from here you can have temp store is equal to our right value, 2. And then right is equal to the sum of right plus left, because we're overriding right. And then left can be equal to temp. And we should be able to reach all the way to the end of the sequence, and left should be the thing at the end of it all. Left should be what we want it to return. So return left. And you might want to do minus n minus 1 because we wouldn't want to go all the way, not too far. So that passes that test, and the main test, and that passes that one. So this solution only uses 2 variables and swaps, well technically 3. So that would, I'm sure, so it would be the same amount of space for whatever input n is, so that would be big O of 1 space. And the time complexity, since we're still going from beginning all the way up to n, that's still going to be big O of n time. But this saves space. So there you go. That's your answer.